Welcome to Ask and Learn.
Hi, here it is given that a particle moves according to the law of motion, which is given that s equal to f of t, where the value of t is greater than or equal to 0. Here f of t is given by 0.01 t power 4 minus 0.02 t cube. In this question, first we have to find the velocity at time t in feet per second, where velocity equal to ds by dt. Here t into, here we are having f of t by dt, so that here we have to differentiate f of t with respect to t, that is differentiation of 0.01 t power 4 minus 0.02 t cube, such that we will get 0.04 t cube minus 0.06 t square, which is v of t, that is the velocity at time t, which is feet per second. And then we have to find the velocity after 1 second, so that here we have to substitute t equal to 1, such that v of 1 equal to 0.04 minus 0.06, hence the value will be minus 0.02 feet per second, which is the velocity after 1 second. And then we have to find the time t when the particle is at rest. When the particle is at rest, the velocity must be equals to 0, such that we will get 0.04 t cube minus 0.06 t square equals to 0, such that we will get t square into 0.04 t minus 0.06 equals to 0, such that t equal to 0 or 0.04 t equals to 0.06, such that t equals to 1.5. Hence we can say that t equal to 0 seconds, which is the smaller value, and t equal to 1.5 second, which is the larger value. And then here we have to find the particle is moving in positive direction, where the particle is moving in positive direction if the velocity is greater than 0, for the value of t is greater than 1.5. Hence we can say that at 1.5 comma infinity, on 1.5 comma infinity, the particle is moving in positive direction. And then we have to find the total distance traveled during the first 10 seconds, so that here we have to substitute t equal to 10 f of t, such that 0.01 into 10 power 4 minus 0.02 into 10 cube, which is equals to 80 feet. And then we have to find the acceleration at time t, where a of t equal to dv by dt, that is differentiation of the velocity with respect to time t, that is d by dt of the velocity is 0.04 t cube minus 0.06 t square. By differentiating this, we will get the a of t equals to, that is the acceleration equal to 0.12 t square minus 0.12 t feet per second square. And then here we have to graph the velocity, position and acceleration for 10 seconds, so that here we will get the graph that here the graph represents the position, velocity and acceleration at time t up to 10 seconds. And then here we have to find the speeding up and speeding down, so that for speeding a of t equals to 0, that is the acceleration at time t equal to 0. Here a of t is 0.12 t square minus 0.12 t equals to 0, such that we will get t into 0.12 t minus 0.12 equals to 0, such that either t equal to 0 or 0.12 t equal to 0.12. Hence we will get t equals to 1. So that here we can say the particle is speeding up. Here we can say that we can consider 1, that is time t equals to 1. Here from 0 to 1, the sign of a of t, which is negative, and from t to infinity the sign is positive. So that here we can say that the particle is speeding up when 1 less than t less than infinity, and slowing down when 0 less than t less than 1. Also we can write it as speeding down when it is 1, 0, 1, and speeding up (1, infinity). I hope you understand the solution. Thank you.